Homework solutions for section 2.3. This is a rational function. We're asked to present everything. My first step, of course, has to be fully factor the function. Do not simplify before you state the domain. The domain of this function is anything but 1 and -1. Anything but -1 and 1. After that, I can simplify, and I know that when a factor simplifies, that factor becomes a whole, not a vertical asymptote. The factor that stays in the simplified form becomes a vertical asymptote. Of course, I need the limits left and right, as well as the limits at infinities, and the x and y intercepts. So I plug in 0, and I get 1. 0, 2 over 2, 1. I solve the equation f of x equals 0, but I have that right there in front of me. This is a fraction. A fraction is 0 when the top is 0. That's how I get x equals -2. 0, 1, -2, 0. Now I would like to determine the limits. The limit from the left, the limit when x approaches -infinity or infinity will be the same. I'm using L'Hopital's rule because it's infinity over infinity. I differentiate the top, I get 1. I differentiate the denominator, I get 2. So the answer is 1 over 2. I did not drop the limit operator yet. Now I can. Y equals 1/2 is the horizontal asymptote, and I make myself a note. 1/2, 1/2. Y equals 1/2, a horizontal asymptote. After that, I want to determine the limits left and right of -1. Of course, it's 0 in the denominator. But -1 from the left with -1.1, the numerator is positive, but the denominator is negative. And the answer is -infinity. -1 from the right with -0.9, the numerator is still positive, but now the denominator is positive. That's why -infinity, positive infinity, x equals -1, a vertical asymptote. -infinity, positive infinity. And also, the limit as x approaches 1 from either side of x plus 2 over 2 times x plus 1, 1 plus 2 is 3, 1 plus 1 is 2, times 2 is 4. So this is the whole. 1, 3/4 will be the whole. Moving on to the first derivative. You know me, I try to make it as simple as possible. 1 over 2 stays outside. I'm not going to involve this. You can wait patiently. X plus 2 prime is 1 times the denominator minus x plus 2 times the denominator prime, which is 1, but I have to distribute -1. So I have -1 over 2x plus 2 squared. This is a positive number all the time, but it has a minus in front. So there will be always less than 0, never equal to 0, no critical numbers. The function is always decreasing. And now I make sure that these two rows go well together. Always decreasing, yes, from 1/2 to 0 to -infinity, yes. From infinity to 1 to 3/4 to 1/2, yes. At this point, I'm ready for the second derivative. But you know, again, to simplify this and have -1/2 x plus 1 to -2. I bring down -2, which will eliminate this. X plus 1 to -3. 1 over x plus 1 to the third power. I will, just for the purpose of studying the sign, I will split it like this, because I don't need to plug in this piece anything. It's always positive. So to the left of -1 will be negative, plug in a number, and to the right of -1 will be positive. The function opens downward, concave downwards, upwards, upwards. No inflection point. The derivative, the second derivative, is never 0. Okay, or undefined. So here's the graph, always decreasing from 1/2 to -2, 0 to -infinity, from 1/2, -2, 0 to -infinity, from positive infinity, 1, 0, 1, now it goes through the whole, 1, 3/4, and then it continues to decrease towards the horizontal asymptote, which is 1/2. We were not asked to find the range, but I wanted to make sure everything under 1/2, from 1/2 to 3/4, because it's a whole here, and then from 3/4 to infinity. This function, we are told that v is in hundreds of dollars. So we were asked to find when t is 0, 5, 10, and 70. I've just plugged them in the function in the calculator, but v is in hundreds of dollars. So the answer is not 50, but 5,000, and so on and so forth. Then I'm asked to differentiate this function. When I differentiate 50, I get 0. Negative 25 has to stay outside. The function prime at the top is 2t times the denominator minus the function times the denominator prime 2t plus 2 to 1 times the inner function prime, but it's 1. Of course, I will factor out t plus 2. I have 2t times t, 2t times 2, and then minus 2t squared. These two go away. One of these factors go away. So the answer at the top is negative 100t over t plus 2 to the third. Because t is a number from 0 to infinity, this quantity is always negative. Always negative. So the function is always decreasing. I have to show that. Where is it 0? At 0. Not sufficient. Of course, it's 5,000. I already have the answer. But I have to determine this limit to show that indeed, again, do not conclude. You have to determine these. So I have to find the limit at infinity. So here it is. Limit of all this is the limit of 50 is 50 minus the limit of this. It's infinity over infinity. I cannot write it here because there is a 50 in front. But I will proceed with L'Hopital's rule here. I copy 50. 50t I differentiated 2 times this minus. I differentiate again because this is infinity over infinity. I get 50 over 2, which is 25. 50 minus 25 is 25, which is actually 2,500. That's how why I have 2,500 here at infinity. So it's at time t0, the inventory is 5,000. It continues to decrease till 2,500. Thank you.